this lesson we are going to learn about the zero factor theorem. This reminds us that a binomial, for example, when you put those letters in there, it sometimes looks confusing, but like x minus 3 is a factor of the polynomial if and only if f of a equals 0. So f of 3 equals 0. That's the factor theorem. So as we do this, we're going to now use all the things we've done the last few days to find the zeros of a rational function. First, we're going to list all the possible factors, which we learned how to do in our last lesson, where we listed the factors of the first term and the constant, and then we did p divided by q. Then we're going to plug those factors in until we get one that equals 0, which is our factor theorem, which we've done before, you might not remember. And then we're going to use that factor to long divide, so we did long division a couple videos ago. And then we'll factor what's called the depressed polynomial or use the quadratic formula. That might be a term you're not familiar with, so when we get to that I'll explain to what that means. I think it'll make more sense when I actually can show it to you. So to start, we're going to be given a function here, h of x, and we're going to first find all the zeros of the function. So we're going to first list all the possible factors. So the factors of 6 are 1 and 6, 2 and 3, and then the factors of 2 are just 1 and 2. So to list all of those, I'd have 1 divided by 1, 1 divided by 2, 1 divided by 3, and 1 divided by 6 for the 1. And then for the 2, I'm going to do the 2 next. 2 divided by 1, 2 divided by 2, 2 divided by 3, and 2 divided by 6, which is 1/3. So my repeats, 1 repeated and 1/3 repeated. So when I write them here, which we did this the other day, so hopefully you're remembering that, I would have plus or minus, my smallest fraction is 1/6, then 1/3, 1/2, 2/3, and then plus or minus 1 and plus or minus 2. So all of my possible options for roots for this polynomial are the 24 up here, because there's, excuse me, 12. There's 6 numbers, so with the plus or minus we have 12 options. What we need to do now is pick some options and plug them in to see if we plug it in which one gets us equal to 0. The reason we're doing that, just so you can kind of remember what that factor theorem is, if you think of a graph, and where the graph crosses the x-axis is our zeros, right? So for this one I'm just sketching quick. My zeros are here. Well, if I was to label these points, I'd call this point like -3, 0. This point would be, let's say, 2, 0, and this point is, say, 6, 0. Notice all of my y-coordinates are 0. So when I plug in this value, whatever the number is, if it's a 0 or an answer or a solution or a root, I'm going to get 0 when I plug it into that equation. Because when I plug it in for x, I should get 0 for y. So we're going to have to pick of these 12 options here now. We have 12 to choose from. I personally always choose my integers first just because it's a pain in the butt to do fractions, I think. So I'm going to pick either plus or minus 1 or plus or minus 2. So to start, I'm just going to start with, let's say, 2. Okay, I'll work backwards on these since I have all the fractions that way. So my first option I'm going to try is 2. So I'm going to say, with my original problem, it's h of x. So I'm going to say h of 2, because I'm plugging 2 in for x, equals 6 times 2 cubed plus 11 times 2 squared minus 3 times 2 minus 2. Now, when I simplify this here, I'd get 8 right there, right? So 6 times 8 is 48. And 2 squared is 4, so plus 44 minus 6 minus 2. Well, I can tell right now that's not going to be 0, right? So right now I've eliminated the positive 2, so I'm just going to erase that. So I'm doing a process of elimination. Now hopefully you guessed right, because this is really a pain to go through all 12 options, isn't it? Now I'm going to try negative 2. So h of negative 2. I would have, if I plug it in again, 6 times negative 2 cubed plus 11 times negative 2 squared minus 3 times negative 2 minus 2. Negative 2 cubed would be a negative 8, and then times 6 would be negative 48. Negative 2 squared is still 4, so plus 44 plus 6 minus 2. So this is negative 4 plus 4. Look at that. Winner, winner, chicken dinner. We got h of negative 2 equals 0. So that means one of my answers to this problem is x equals negative 2. That is where the graph crosses the x-axis for sure. Now, how many places does it cross the x-axis? Remember, you look at the original. Our degree is 3, so we should get 3 answers for this problem. So once we find that our x or excuse me, x equals negative 2, to write that as a factor, I'd write x plus 2, right? So I'm going to use the factor, the x plus 2, to do long division. So I will divide out x plus 2, and I'm going to take that root out of my problem. So I'm going to divide it into 6x cubed plus 11x squared minus 3x minus 2. The reason I'm doing this is once I take out this x plus 2 and see what times x plus 2 makes 6x cubed plus 11x squared minus 3x minus 2, then I have what's called our depressed equation, or our depressed polynomial. And that I hopefully can factor or use the quadratic formula on to find the other two roots. I can't find them unless I take the x plus 2 out. So using my long division, I'd say how many times is x going to 6x cubed? That'd be 6x squared. And then distribute that. Remember, we do the negatives here. So I have negative x squared minus 3x when I go ahead and bring that down, right? So how many times does x go into negative x squared? That'd be negative x. So I have negative x squared minus 2x. Change my signs. So I have negative x minus 2. X goes into negative x negative 1 times. So I have negative x minus 2. And look at that. My remainder is 0. If my remainder was not 0, this would not be a solution to my problem. So it has to be a 0, or else I did something wrong when I was working up here. Because that should have been a 0. Isn't that what I got? I got 0. So it should have divided evenly. So now, this right here is my depressed equation. So we're going to use this depressed equation to either factor it or use the quadratic formula. I don't care which you use. I personally choose factoring because I think it's faster, but if you like the quadratic formula, go for it. If I couldn't factor it, I would use the quadratic formula. And that would only happen if you have imaginary roots. Otherwise, you should be able to factor it. So now, for my factors of 1 and 6 are 2 and 3, and I have just 1 and 1 here. So I know this is going to be a 1 and a 1, plus and a minus, and I'm going to assume that 2 and 3 are what works, right? So let's just plug them in. 2x and 3x. When I check that, I'd get 6x squared minus 2x plus 3x minus 1, which ends up giving me a positive x here, and I need a negative x. So that tells me that I need to switch my signs, right? Remember doing that with our factoring? So here are my other two factors, which means I can find my roots. Remember, if you want to find the roots, you just set them equal to 0 and solve. So I have 2x minus 1 equals 0. 3x plus 1 equals 0. So 2x equals 1. One of my other solutions is x equals 1/2. And this one would be x equals negative 1/3. Then I take my 1 from above, because remember there should be 3 answers. So I'm also going to write x equals negative 2. Now what I want to point out here is, look at my very, very top up here. Remember, these are my answers I just found. Negative 1/3, 1/2, and negative 2. Are those options that were given to me in this box right here? They are, right? Here's negative 1/3, positive 1/2, whoops, and negative 2. So I could have chosen any of those 3 and they would have worked out for me, which is nice. I had 3 options there to go from. And if you have a real solution, whether it's positive or negative, it should be listed in this list of possible zeros. The only ones not listed in here would be your imaginary solutions. Those are the only ones you wouldn't be able to find. So a lot of work for one problem. Takes quite a while to go through, right? We've been recording for a little while. We're going to do 2 more like this to kind of get the hang of it. If you feel like you want to try one, pause the video and like fast forward to see if you get the same answer as me, feel free to do that. But I'm going to keep going here and start number 2. Number 2, I again have a cubic equation or function, so I'm going to have 3 answers. When I list the possible factors, the first one is just 1 and 1, and the last one, factors of 12, are 1 and 12, 2 and 6, 3 and 4. So those are all my choices there. Since it's a 1 and 1, I can eliminate one of those. Everything's just going to be divided by 1, so I can pretty much just list these last factors here. So plus or minus 1, 2, 3, 4, 6, and 12. Now, I have to decide which ones I want to plug in to get 0. So I normally work left to right. We'll see if that helps me or not. But I'm going to plug in a 1. So I'd say h of 1 equals 1 cubed minus 1 squared minus 8 times 1 plus 12. So 1 minus 1 minus 8 plus 12. That'd be 4. Doesn't give me a 0. So positive 1 is out. Next I'll try negative 1. And I'm actually just going to keep what I have here and switch this to a negative quick. There we go. So negative 1 cubed is negative 1. Negative 1 squared is 1, so it'll be minus 1. Negative 8 times a negative 1 is plus 8, and then plus 12. That definitely does not equal 0. So this is out. So now I've gone through my choices. 1 is not an option that works for this problem. So then I move to 2. H of 2. I would have 2 cubed minus 2 squared minus 8 times 2 plus 12. So 8 minus 4 minus 16 plus 12. This would be 4 minus 4. Woo! Winner. There we go. Oops. H. So H of 2 equals 0. I found my 0. So one of my zeros for sure is x equals 2, which makes the factor x minus 2. So I'm going to use that to do my long division and get my depressed equation. So I factor with the original here. And then I'm going to do my long division. X goes into x cubed, x squared times. So I have x squared minus 8x, so plus x squared minus 2x. I get negative 6x plus 12. That'd be negative 6. Negative 6x plus 12. Boom, boom. My remainder is 0, just like I expected. So here's my depressed equation. So I'm going to bring that down to my next step. And I'm going to try to factor this. X squared plus x minus 6. So I'd say that'd be x plus 3x minus 2. Does that look good? X plus 3x minus 2. So now I get, set those equal to 0 and solve. X plus 3 equals 0, x minus 2 equals 0. So x equals negative 3 and x equals 2. What was my answer I got up here again? Ooh, it was 2. So I got 2 twice, didn't I? So what that tells me is that x equals 2 is a double root. So remember when we looked at the graphs, just to remind you of that, when we would see a double root at let's say 2, that's where the graph comes down. Instead of going through the root, it bounces back up. It's a really bad looking graph, but I hope you get the point. Normally they would go through the root. This one would bounce back up, and if it was coming from this direction, it'd bounce back down. So whichever way it's coming in from, that's what that looks like. Alright, last one. Again, feel free to try this one on your own. My possible factors here, it's nice, 1 and 1 again, so just a 1. And then 15 is 1, 3, 5, and 15. So my possible factors are 1, 3, 5, and 15, all with a plus or minus in front. See how this kind of gets a little bit quicker as you go? Now, to plug in and check, I'm going to start with 1 again. So I'd say h of 1 equals 1 cubed minus 7 times 1 squared plus 17 times 1 minus 15. So 1 minus 7 plus 17 minus 15, this would be negative 6 plus 2, does not equal 0. Next, I'll try the negatives. I'm just going to go ahead and put a negative in these spots here. Negative 1 cubed is negative 1. Negative 1 squared is 1 times a negative 7. Negative 7. Ooh, this is not going to equal 0. Huh? Alright, so now 1's out. Let's hope it's not 15 for this one. This might take me a while. See how this could be kind of a little bit of a pain having to check all of these? This is why calculators are nice for us. Now I'm going to try 3 next. So h of 3 equals 3 cubed minus 7 times 3 squared plus 17 times 3 minus 15. 3 cubed is 27, 3 squared is 9, so minus 63, plus 17 times 3 is 51, minus 15. So let's see here, I have 27 minus 63. I'm just going to add my positives here, because I'm thinking you might be doing this in your head. So here are my positive numbers. I have 78, and then minus, and I'll add these negative numbers. Ooh, 78. Oh, look at that. We just found our root. H of 3 equals 0. So 3 works. So that means h minus 3 is the factor that would equal an x value of 3. So I'll use h minus 3, and I will factor that into my original problem, which was x cubed minus 7x squared plus 17x minus 15. So we're going to use our long division here. How many times does... Oh, I actually used x's and h's, didn't I? Let's call this an x. I didn't mean to call it an h. I don't know where that came from. So now I'd say how many times does x go into x cubed? That'd be x squared. When I go ahead and add here, I get negative 4x squared plus 17x. How many times does x go into negative 4x squared? It'd be a negative 4x times. So again, I distribute that there. This is getting you good practice for long division, huh? I go here, boom, boom. I have 5x minus 15. How many times does x go into 5x? It'd be positive 5 times, which gives me 5x minus 15. So like I was hoping, that's a root, right? So here's my depressed equation. And I'm going to go ahead and try to factor this. So it's x squared minus 4x plus 5. So what happens here is I'm going to look and say x minus 5x plus 1. And a lot of people will write this as their answer, but if you notice, when I FOIL this out and I distribute this here, I would get a negative 5 as my last term, and I need it to be a positive. So this doesn't actually factor, which leads me to believe I have imaginary solutions here. When I can't factor it, I'm going to use my quadratic formula. If you don't remember what that is, I'll write it down here for you so you can keep it in your notes to use on your worksheet. Remember, it's always in the top of our classroom too, in the middle of the room. So when you look there, now I'm going to go ahead and plug in a, b, and c. It's been a while since we've done this. So I'd say x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 4 squared is 16, and then minus 20 over 2. X equals plus 4 plus or minus the square root of negative 4 over 2. And so I was correct in assuming I had an imaginary solution, remember. The square root of negative 4 is plus or minus 2i. And if you remember, we can reduce all of these as long as it's all of them. So my root is actually x equals 2 plus or minus I. Now, my other root from earlier up here was x. This is where my h came from. That should be an x. X equals 3, right? So 3 was my other root that works. So x equals 3, and x equals 2 plus or minus 2i. And that's my answer. Now, if you're thinking our problem should have 3 answers, there should be 3 different roots, and we only have 2. We actually do have 3 because 2 plus I is one root. Oops. 2 plus I is one root, and 2 minus I is one root. So if you wrote them separately, you could. We do prefer you to put them together just to save you some space. Hopefully that makes sense. So if you have any questions on this, please let me know tomorrow and we can go through it.